Let's see the Fourier transform of the given signal this way, the rectangular kind of a pulse. So these kind of problems are very important. So if we have a rectangular pulse of whatever the amplitude, and it may be any range, it may be t or t by 2, we'll see those all things later. So let's solve one such kind of a problem first. Now when we are given with the signal, then how do we write this signal? We write the signal as our x of t is equal to, as the given signal is in this fashion, as it is in this way. It is having a rectangular pulse in this fashion. This is t, and the values are from plus t, minus t, its amplitude is 1. Plus t, minus t, its amplitude is 1. Okay. So let's solve this problem. So to solve this problem, x of t has to be defined. So how do we write the x of t? X of t is written in this way. X of t is 1. X of t is 1 when our t is in between minus t to plus t. So let's write minus t. So now this t is less than or equal to, the small t is less than or greater than or equal to the small t, then, or if it is less than or equal to capital T, the value of our signal is 1. And it is equal to 0 when the signal is other than this range. So elsewhere, or we can write otherwise. So it is otherwise when it is other than this range, the signal value is 0. Okay, let's solve. The equation which we have to use, the Fourier transform, is given by the equation x of j omega, and this x of j omega is equal to the integration from minus infinity to plus infinity x of t e raised to minus j omega dt. So we know this equation. So let's go for substituting these values, and when we go for substitution, this value is 1 only in this range, and it is 0, means the integration will be from minus capital T to plus capital T. It is x of t is 1, no need to write it. So first time, let's write. Now it has to be e raised to minus j omega t. So let's write e raised to minus j omega t dt. We know it is as good as writing e raised to minus j omega t. The integration of e raised to minus j omega t is, it is e raised to minus j omega the t divided by minus j omega, and limits of the integration are from minus t to plus t. Now when we solve this, we get this one as e raised to minus j omega this is capital T. So we get e raised to minus j omega the capital T, and minus e raised to minus minus e raised to j omega the minus t, which will make it as plus t, and divided by j omega. Now, for these kind of problems, we get such kind of an exponential term, and this exponential term has to be solved. Now we know that sine expansion, and this is minus sine expansion, is e raised to j omega and e raised to minus j omega. So we can write this one as, let's write it here, it is e raised to plus j omega t divided by j omega. Now this, let me replace by, it is our x of j omega. X of j omega can be written as, now this is sine of, now let's write this one as, but to write this one as sine of omega t, we need to have 2j, so let's multiply here. So this entire factor is multiplied by 2, and even this is multiplied by 2, so 2j we take, so this becomes 2, this 2 remains as it is, sine of omega t, and in the denominator omega remains. Now in these kind of problems, the integration, the x of j omega value is given in this fashion. X of j omega is given in this way, is equal to this x of j omega. When we go for calculating, we know that after calculating this Fourier representation, this magnitude and phasal plots have to be drawn, and for that we need the different values of omega, and the different values of omega will be, omega is equal to 0, 1, something, these values they could be. And in this sine of omega and calculating, so for these problems it should not be done. So we use an expression, we use sinc function. So what is a sinc function? So sinc is one of the mathematical function which will be most widely used. So sinc of, we can find any variable. Let's say sinc of u, S-I-N-C u, sinc of u, we may write it in bracket also. So this is equal to sine of, this is equal to sine of pi u divided by pi u. So this is equal to sine of pi u divided by pi u. So this sinc function is this kind of a function wherein sinc of u, if we are writing, we can write sinc of t also. So we have written sinc of u. If sinc of u, any variable it is, then it is sine of pi u divided by pi u. If it is sinc of t, if it is sinc of t, then certainly it has to be sine of pi t divided by sine of pi t divided by pi. In this way it will be given. So it may be for any variable. So we should remember that it takes the highest value for u is equal to 0. When u is equal to 0, its value is 1. The sinc function takes highest value, that is 1, when u is 0, and when this is equal to, this pi u is equal to pi, when this pi u is equal to, when this pi into u is equal to pi, because we know that sine takes its 0 value, first value at pi, because sine of pi is 0. So u is equal to 1 we get. So the value u is equal to 1. So means this is 1 and this is minus 1. So in this way this would be 2 minus 2, and so on up to, it runs up to 2 pi. So this is our sinc function. Now we need to use, and even the L'Hospital rule. By means of that we have to solve this, and the same process, the same result will get even by L'Hospital rule. Now we need to get this equation to the sinc form. Means we have sine of omega t. So even we should have t here so that we can write it as the sinc expansion. So to do that, let's write t here, and as we are writing t here, let's multiply it by t also. So the equation is not changed. Now to this I can call as it is r. So this can be written as it is 2 into t. Now for this, let's write it is sinc of, it is sinc of omega t. So it is sinc of t. So we write this one as sinc of t. And we draw the output of this signal. So there is nothing like magnitude and phase, because x of j omega, when we see this x of j omega's expression, x of j omega expression is given by, it is integration 1 divided by 2. So the definition of Fourier transform gives x of j omega is equal to like 1 by 2 pi x of j omega, x of t is equal to, we have, means it indicates that, the further terms, it indicates that our frequency domain signal is continuous in nature. So let's go for drawing that signal. So what is this sinc of t? Let's complete. So the output of our signal is in this way. Now the signal will be sinc form. Let's draw in this way and even in this way. Here 0, those are omega. Now the highest amplitude at t is equal to, at omega is equal to 0, the value, we need to look at this equation. When omega is equal to 0, the value taken by the signal is 2t. So it takes, because this term goes 0, or even we can write by L'Hospital rule. So this is into 1. So the value taken at omega is equal to 0 is 2 into t. And where the first minima takes place. So to get the first minima, we need to write our omega t. Let's look at the sine term. This sine of omega, omega into t should be equal to pi. So for what value of omega the first minima happens? When omega is equal to, because we know the first minima happens in case of sine at sine is equal to pi. Omega is equal to pi by t we get. Means this value is plus pi by capital T. Similarly, this value is minus of pi by capital T. And the next one would be this 2 times the multiples of this. It continues. If this implies that if t, the capital T, which is this one, if the value of this capital T is 1 second, if it is 1 second, then it is pi by 1 itself, means at pi, and this is 2 pi. So this would be the nature of our signal. Hence we'll be having this kind of a signal. That's it. In case of frequency domain, so this makes it as, because here it is pi, here it would be 2 pi. So we need to draw it, the frequency domain graph, over the range of 2 pi. So let's say minus 2 pi here and plus 2 pi. If our t is equal to 2 seconds, if our t is equal to 2 seconds, then this is pi by 2, hence this is pi, and 3 pi by 2 and 2 pi. Means we'll have, if t is equal to 2, if t is equal to 2, then the graph would be in this fashion. Certainly this will be the magnitude. The first minima happens at pi by 2, and second one will be at pi. Means we have this even, this lobe, and then this would be our pi. Then the next one would be another pi by 2, so which will be 3 pi by 2, and then another cycle. So we'll have the number of lobes they exist. The number of lobes existing depends on, within the duration 2 pi, depends on the value of t. So this is a very important problem. I hope you all understood this. So this problem is solved and it's given in this way, and the nature of your output would be in this signum form. It is in the sinc form, and minus pi by t and plus pi by t. The next problem is the finding Fourier transform of 1. So when we are given with del of t, its value is 1, we have seen. So let's find the Fourier transform when x of t is equal to 1. Now in this case, we have some conditions to go for Fourier representations, and one of them, it should have the finite number of maxima and minima, and the second one is it should have finite number of discontinuities, and the third one is the signal should be absolutely integratable. So now here the signal is not integral, so we can't find the integration of this one, because the Fourier equation x of j omega is equal to, we go for writing it, and the value of e raised to, now x of t is 1 e raised to minus j omega t. So this integration will have e to the power j omega minus infinity and e to the power of j omega plus infinity, which makes it not integrable. It is not integrable. So as it is not integrable, we need to go for some other method, and for this we use the method by using a property called duality. Duality is one of the important property of Fourier transform, which says like, if x of t and x of j omega are the time domain and Fourier domain, Fourier transform domain representations, then when we exchange the variables, now we use t with the time domain signal and omega with the frequency domain signal. If we exchange, means with this j we are using t, and with this x will be using x of minus omega. So the derivation of this property shows that x of jt is equal to 2 pi x of minus omega by using the duality property. So we use the same here. As del of t, we know that del of t, just we have found the del of t's Fourier transform in the last video. The Fourier transform of del of t is 1. So we make use of that thing. Fourier transform. So we write Fourier's on the right side, time domain signal on the left side. So Fourier transform of del of t is 1. So we use that. Now let's exchange by using duality property, let's write this 1 here and 2 pi as it is. In place of x, now our x of signal is del of t, because that is the signal we want to find. So x of minus omega will become del of minus omega, and we know del of impulse signal only one value will be there and it is even. So del of minus omega is equal to del of omega. Means when x of t is equal to 1, its Fourier transform is 2 pi del of omega. So this is also one of the important thing. Then the next thing is the Fourier transform of signum function. The Fourier transform of signum function x of t is equal to sgn t. The signum function is given in this way. So sgn of t is equal to 1 for t greater than 0 and is equal to minus 1 for t less than 0. So the signal looks in this way. For t greater than 0 it is 1, for t less than 0 it is minus 1. Now for this signal x of t is equal to, so we need to write up the equation. So what is the equation for x of t? So let's write it. This signal, as this is full, now this signal looks in this fashion. Now we need to write the expression for the signal. The expression for the signal, let's look. Only the positive portion, that is when t is greater than 0. So it is nothing but u of t signal. So let me write sgn of t is equal to u of t. But it is not entirely u of t because we have this part too. Then to write the equation for this part, what we can do is, it is minus and it is running in the reverse direction. If I know how is my u of minus t signal, so if I ask you to draw the u of minus t signal, you will draw in this way. Now for this part I can write u of minus t, but it will be lying above 0, but it should lie below 0, and to make that way we should write, if the signal has to be in this fashion with minus 1, if it has to go at the 0th instance, then I have to write it as minus of u of minus t, minus of u of minus t. So sgn of t is nothing but u of t minus of u of minus t. So this signal we need to, now by using the differentiation property as it's given over here, it is being done by using the differentiation property. So d by dt of x of t is being done, which makes it quite simple. So the differentiation will simplify, that's why the properties are there. Now this is our x of t, and x of t is equal to this much. If we go for finding d by dt of x of t, d by dt of x of t is nothing but differentiation of this above equation, that is sgn of t. So differentiation of u of t is del of t. Differentiation of u of t is del of t. And differentiation of u of minus t is, certainly for this we get, minus sign is already there, differentiation of minus t for this signal, it would be minus of del of t. So as it is minus of del of t, so when we add this, we get this one as 2 into del of t. So d by dt of x of t is equal to 2 into del of t. I hope you understood how this 2 into del of t is the result of the signum function. Then once we have obtained this, then the process is very easy. X of j omega is equal to what? X of j omega is the Fourier transform is taken on either side. X of j omega into x of j omega, because we know that the Fourier transform of d by dt of x of t is j omega into x of, the differentiation property is d by dt of x of t is equal to j omega x of j omega. Now d by dt of x of t's value we have, it is 2 into del of t, but the value of del of t is 1, so we write it as 2 j omega into x of j omega. So as this del of t is d by dt of x of t is 2, del of t's Fourier transform is 1, so we write it as 1 itself, j omega x of j omega. So the value of x of j omega is equal to 2 divided by j omega. It's equal to 2 divided by j omega. The same here, 2 divided by j omega. We need to go for finding its magnitude as well as the phase. If the magnitude of this one is going to be 2 by pi, because it is 2 root of 2 square divided by root of omega square, real term is 0, and the angle is, now how to find this angle? I hope there is no confusion with this magnitude, otherwise let's do it. The magnitude of this x of j omega is equal to, it is 2 divided by root of omega square, so which is nothing but 2 by omega itself. Then angle of x of j omega is equal to, now angle is contributed only by the denominator, there is no angle by numerator, so it is a 0 minus denominator means it is a j, so we can think it as 0 plus j, so tan inverse of, we can write tan inverse of y by x, but our y is existing but x is a 0, so tan inverse of omega divided by 0, so which makes it as infinity, which is nothing but minus of pi by 2, or even one can conclude like j means it is contributing pi by 2, as it is in the denominator. When we take it to the numerator, it becomes minus pi by 2. So in any ways we can go for, and then we need to plot the magnitude and phasal plots of this. Then what is the plots of this? Well, when omega is greater than 0, when omega is greater than 0 means positive, then this angle would be pi by 2. This angle would be pi by 2. When by considering this omega as greater, we have taken it as minus tan. When this omega is greater than 0, when this omega is less than 0, means we'll be having this minus. That time it becomes plus pi by 2. So the graph becomes magnitude of 2 by pi. So the magnitudal plot of this one, let's draw. Let's guess how it would be. It is 0, 1, so on, and negative. And we know it has to be always a symmetrical graph. So 2 by 0 will be having. 2 by 0 is infinity, means it is very high value. When omega is equal to 1, its value would be, let's say, 2. If 2 is here, then its value is 2 at omega is equal to 1. When omega is equal to 2, its value is 1. Means when omega is equal to 3, 2 by 3. So the graph decreases in this fashion. on either side, but its value is infinity at omega is equal to 0, which cannot be shown. And at omega is equal to infinity, its value would be almost 0. This way it goes. Then the phase would be, of course, given in this way. When omega is greater than 0, it is minus pi by 2. So fixed it is. Let's say it is minus pi by 2. And when omega is less than 0, it is plus pi by 2. So in this way it is, let's say it is plus pi by 2. That's it. The next kind of problems wherein we need to find we have to make use of properties to make the solutions easier. So let's see such kind of problems. So find Fourier transform of the following signal using appropriate properties. If x of t is given and it is sine of pi t e raised to minus 2t u of t, we can go for its Fourier transform. Now given sine, first thing is we need to expand the signal, sine signal. When we expand it, so it takes this form, e raised to minus 2t as it is into u of t, and we multiply this all and get it to this form. I don't think any confusion at all. Now to solve it further, in place of solving it like by using the equations, we have to make use of properties in these. Now e raised to minus 2t e raised to j pi t u of t. Now to solve this, we know that if it is e raised to minus 2t into u of t, how is that given? So the very first problem we have solved, e raised to minus 80. So we have to make use of that. Signal's output was, the Fourier transform of that one was 1 by a plus j omega. So we use that. So that problem was e raised to minus 80 into u of t multiplied. So which has given this answer. So no need to do it further. We go for solving. This is a semicolon. So by that property we can write the Fourier transform of the signal as it is 1 divided by a is 2 here. So 1 divided by 2 plus j omega. So we are making use of properties now, and we are not having only this much, we are having e raised to minus 2, and if it is multiplied with e raised to j pi t, then if e raised to j beta t we have seen, so it is a frequency shift property. By using the frequency shift property, if e raised to j beta t was there, its Fourier transform was x of j omega j in the bracket omega minus beta. So similarly, wherever there is omega, we'll be replacing it by omega minus whatever is the value over here. So e raised to j pi t, e raised to j pi t into e raised to minus 2t's value becomes e raised to j pi t into e raised to minus 2t into u of t. So the Fourier transform of this signal, so we need to write the Fourier transform of this e raised to minus 2t into u of t signal only. Let's write it, 2 plus j. Now while writing omega, we have to take this term, so it becomes e raised to j omega, not just omega here, it is omega minus this term, except this j and t, whatever is there, it is this one. So we need to write this kind of a term for another also. For another also, e raised to j pi t. Now if it is e raised to minus j pi t, then it would be plus. Now it is 1 by, if it is 1 by 2j e raised to j pi t, then 1 by 2j is a multiplication, just it becomes 1 by 2j, the same thing what we have written. 1 divided by 1 by 2j is multiplied on either side because it is there in our problem. So we have 2j, 1 by 2j multiplication with this. So the Fourier transform of this all is this much multiplied by 1 by 2j. And for this one, it would be 1 divided by, similarly, 2 plus j omega. This has to be plus. So let's see that. So it is 1 divided by 2 plus j omega plus pi. Then entirely the Fourier transform of x of t, that is sine of pi t e raised to minus 2t into u of t is. Now 1 by 2j is common among, so we write these two terms, and this will be the Fourier transform of our x of t is equal to sine of pi t e raised to minus 2t into u of t. And similarly, another simple problem is that find the Fourier transform of x of t is equal to 2 divided by t square plus 1 square. Now of what form it is? Now when we have this, let's remember which kind of problem has given this kind of a thing. So x of t, x of j omega, x of jt is equal to 2 pi x of minus j omega. So we are using a duality property here, and e raised to, before that, e raised to minus a magnitude of t has given what answer? It is 2a divided by a square plus omega square. So if our x of t is equal to e to the power minus of magnitude of t, means if the value of this a is a 1, then we get 2 divided by 1 plus omega square, and to get this t we are using that duality property. So j is replaced, now omega and t are replaced. This x of j omega it is. So here we write t and 2 divided by t square plus 1. A duality property, so which says that x of minus x of jt is equal to 2 pi x of minus omega t. So let's see that. When we replace this, we are getting 2 divided by 1 plus omega square, then omega is replaced by t, we get 2 divided by t square plus 1, which is same as that of 1 plus t square. So by duality property, it is 2 pi into x of minus omega. So we write 2 pi into x of minus omega. Our x is e raised to minus magnitude of t. So it is 2 pi, our x is e raised to, our x is e raised to minus of magnitude of t, but this minus omega we need to write, so replace t with minus omega. So we are having this kind of a segment, and we know that minus of omega's magnitude is equal to omega itself. So this is the segment. So this completes the Fourier transform problems using properties also, and all different kinds of problems. We'll see DTFT in the next video.